Okay, so we're now going to charge up our capacitor and study the voltage against time, and then we are then going to discharge it and then look at the voltage time graph for a resistor connected in series. Now, a typical circuit used to study the charging and discharging of a capacitor is called an RC circuit, and we're going to I'm going to draw the circuit diagram, and then we're going to actually make it using the circuit simulator. So what we do is we have our battery over here, let's say 5-volt battery. We connect a three-way switch here at the top, and when the switch is on this side, we will be charging the capacitor. On this side we have the discharge circuit, and then first we connect a capacitor and then we connect a resistor in series, CR. That's why it's called an RC circuit. And then we join it up here at the bottom. The discharge side is also connected at the bottom at the moment, but it's not connected because the switch is on the charge side. So when it's on the charging side, we have a positive build-up of positive charge on this side, and we have a build-up of negative charge on this side. And when the potential difference across the capacitor equals the potential difference across the battery, will no longer have a current flowing. But while the capacitor is charging, there will be a current flowing from positive to negative. But we're going to see how the current varies with time. Now, when we let's just copy that. So I'm going to take this circuit, the same circuit, copy it, paste it over here. We now let's see. We're going to now flick the switch. We're going to take away, move the switch from this side to this side. Now we have no battery connected. We just have the store of charge, which is going to want to release or discharge its charge, and the current's going to flow from positive to negative, so it's going to flow in the opposite direction. So we should see that the current is going to change sign. Okay, so I hope you're still with me. This is the RC circuit. I have a DC power source connected to a three-way switch, connected to a capacitor and a resistor. The capacitor is 10 microfarads and the resistor is 1 kilo ohm, and the switch is turned, so it should be charging. Now if I just reset and run it, now I am measuring the potential across the capacitor and the current across in the circuit. Now if you look, the current peaks initially and then goes down to 0. So as the charge of the capacitor reaches a steady state value. Now let's look what happens when I discharge the switch. So I'm discharging the capacitor. The current flows in the other way, and we see what's called exponential decay in both the graph of potential and current, and until they get down to 0 again. Now let me just see what happens. We can just investigate the effect of increasing the capacitance and increasing the resistance. So if I was to, let's see, right click on this component here, and let's say increase it by a factor 10 to 100 micro, reset put it on the charging side, reset again. Now, I don't know if you can see that, but it's taking a much longer time for it to charge up. So the effect of increasing the capacitance is that it takes a lot longer time to charge up. Let's just discharge it. Let's reset the capacitance to 10 microfarads, and let's this time increase, let's say we'll increase the resistance 10 times. Reset it, let's see what effect that has. Well, we've got a lower voltage, of course, because V equals IR, but it also takes a lot longer time to charge up. So both increasing the capacitance and increasing the resistance increases the time it takes to charge up and even discharge the circuit. And there are a few equations you have to know in order to solve charging and discharging, or rather discharging of a capacitor.